Record. Okay. So the idea is developing a page like this one. So we don't yet have a page to specify the diffusions, the diffusion fields. So in a biological system, you have the cells, and the cells can, for example, secrete stuff, secrete proteins, signaling molecules, etc. And they can absorb, and these molecules, they in time they spread throughout the tissue. Okay, and this is a very important mechanism in many systems. For example, development. You have the morphogens. That's what defines, for example, how many fingers you have in your hand is determined by the morphogens, and well, many other systems. So this is crucial in the software. All right.
Yeah.
This is a crucial mechanism in the software. So people developing simulations in tissue engineering using CompuCell, they need a page like this, where you have your diffusion fields, field 1, field 2, field 3, etc., etc. And for each one of these fields, you can assign the diffusion coefficient, which is how fast the field spreads throughout the tissue. And you can also assign a decay coefficient, which is how fast that molecule gets cleared out from the tissue. Okay?
Okay.
And you can also set secretion rates for different kinds of cells. Okay? And so this is how the page would look like. You have, instead of OK and close buttons, you will have like previous and next, like we have usually in TwoEdit. But the idea is you have one tab for each field that the person specified. So for example, let's say I specify a field called morphogen 1, another field called morphogen 2. So these names should appear in the tabs. Instead of field 1 would be morphogen 1, instead of field 2 would be morphogen 2.
Okay.
If the person sets, for example, morphogen 1, morphogen 2, 3, 4, 5, 6, 7, you should be able to automatically create all the tabs for all fields the person set up.
Okay.
And in these tables, so in each tab, there will be, the idea is two tables. The first table is to set diffusion and decay coefficients. And the second table is to set secretion rate and secretion value. Those are two different things. And for each one of these tables, you should create one row for every cell type that the user defined. So in this case here, let's say I defined cell A, cell B, and cell C. You should create automatically for as many cell types the user defined, corresponding rows to each one of the cell types. That's the idea. So let me show how it would look like to add it in practice. So this is the original CC3D, the one published. And you are creating your project, and then you set a cell. For example, a stem cell.
Yeah.
And a morphogen. next, next, finish. Okay. So the way it's done, we don't specify the diffusion and decay. It's automatically specified. The software gives you like default values
Yeah.
you did not ask for. So ideally in that page, because I created only one field, I would have only one tab here called morphogen. Okay. And because I defined only one cell type, which is stem cell, we can see here I have only one cell type besides medium. Medium is a default cell type. So stem cell is my user-defined cell type. Because of that, I should see only two rows here, global, which is default. We always need global, and stem cell, because I defined stem cell instead of cell A here would be stem cell,
Yeah.
and these would be the only two rows here. And same thing for the secretion table, we would have the first row medium, and the second row would be stem cell. And we wouldn't have cell B, cell C, and cell C, cell B and cell C, okay? Because this is only an example. Okay, so in this document, which I think we all have access to, if not, I just send to you again, doesn't matter, and I'll probably send an email with the instructions. So I was writing like everything this page should accomplish in order to be fully functional. And then these numbers that the user set, for example, diffusion coefficient global, diffusion coefficient for different cell types, and secretion, they have to be parsed to the XML, all right, the way you learned how to do, and they will be written in those lines. For example, global diffusion constant, this number will be taken from here, global diffusion coefficient, this entry here. And for example, global decay constant, this number will come from decay coefficient global. And for example, in the case of diffusion coefficient for cell type stem cell, this number shall come from this entry, and decay coefficient 0.0001 here, this number shall come from this entry here. Same thing for the secretion. We have a secretion here. So this number should come from this entry right here. So the idea is simple, but executing, I think it's a fair amount of work, because to automatically generate each one of these rows and passing each one of like reading everything automatically in the Python side using for loops and referring, like automatically referring to each one of these entries in a consistent way, and then passing everything to the XML so it gets generated all these values for all fields. So here I have just one field, which is morphogen. If I have another field, let's say morphogen 2, all this stuff here will appear like duplicated, and instead of morphogen here, I will have another field, let's say morphogen 2, like this, and I will have to pass all, like it has to write all constants exactly as the user defined in each one of these tabs. So this is a fair amount of work. And I don't know what, so I should ask Maciek what he thinks about this idea here. And
Great. I think it's great, really. I mean, I like how you, I was thinking actually how to spec it out, like how to design the GUI. We talked about the tab widget, which is field 1, field 2. But I like how you actually picked in a sense, the easiest way to implement it, and I like it. Because let me actually mark it. I like marking stuff. I don't know why. This stuff is a table widget. And this is the easiest way to implement. And I think it's also like very intuitive to set it up. So whatever, Pedro, I was listening. So whatever you said, this makes perfect sense. And this should be, if we can get this done, this would be great. Now, it's not the entire story, because we will need to handle cases like secretion on contact, uptake, but let's not worry about those. I think once we get this functionality working, we are good. So,
yeah.
And I would say even more. What I would do, I would, let's see. I would design I would use designer, just like you did, Pedro, right? But I'm just trying to think. Oh, I see. Okay, let me actually scroll, remove this. I will show you something here. So there is a little thing that I'm seeing here. This guy. So what you did, you created two table widgets. I'm pretty sure. So there's one table widget, another table widget. We can separate those table widgets by we can do some cosmetics. But this is great start. This is very good start. Really, if we can get it to work. So I think, Leo, so the task would be to, given all the cell types that you specified and given all the field names that you specified on the previous pages, let's generate programmatically what Pedro has on his screen.
Okay.
And if you need help, I don't know what's your plan for next week. It's Thanksgiving week, so you're probably on holidays. But if you have time, if you wanna some help, if you want to do one-on-one coding session, or I'll be able to help you out next week.
Okay.
But don't feel pressured.
Okay.
To do it next week. If you have travel plans or anything like that, just make this your priority.
Okay, so so for Leo, then his job would be to create something like this in Designer.
Yeah,
Okay.
great.
Okay.
Without all the automatized stuff in the Python side, just create the page in Qt Designer.
So about that, so we have to be careful here, because I'm not sure, because here's the situation. I'm just trying to, so I'm not sure if you do anything the only thing you can do really in Designer, in my opinion, is to, let's see, is to create maybe a single tab with those table widgets, like here, right? Because you don't know how many fields you will have, and you don't know what the name of this will be. So what I would say is that the task should be to, so in Designer, that's what I would do. The only thing I would do in Designer, I would specify, let me actually erase this. The only thing in Designer you can do really is to insert the tab view. So in other words, you would only add table widget, this guy. You would not be doing this in Designer. This would have to be programmatically inserted. So to do that, to programmatically insert stuff in the Designer, you would have to create layouts. You would have to create layout to be vertical layout, and then you would insert one, let me get rid of this. You would insert this guy programmatically and this guy programmatically. Now the question is, where do you create those layouts? I can check the code where I'm doing something similar, but I think that's what you would have to do. And because this is, I mean, this is nice. This is nice for illustration purposes, but to move things further, we need to have, okay, we need to have a function that inserts a tab into our tab widget. And this tab function has, you know, one table and another table. So you should have function add, you know, add tab for new field, and you would specify field name. And then, yeah, I think that's because designer is, you know, there are limits to what you can do in designer. So I'm afraid that the only thing you can do in the designer is do that. Now, having said that, what you could learn from designer, like what you could get from the designer, you can get the code for that, really, because let me actually erase this again. Because let's say that you create something like that in the designer, just with one tab, okay? So there will be table 1, table 2, that looks like that. And you can create it, right? And then you will use PyUIC5 to generate the code. Well, this code that you generated is essentially the code that you could really almost verbatim take and copy and paste in your function. So yeah, there is value in the designer, but yeah, but you will have to extract the code that PyUIC, who invented this name, generates, and take this code and put it in a separate function. Like literally copy and paste, and you know there will be some really minor modifications, but I think this will do the trick. I'm pretty sure that it will do the trick.
Yeah, so that's exactly the reason why I think he should replicate this design fully.
Yep.
So with at least like with 2 tabs.
Yep.
And with 2 tables inside with all the default parameters. Yep. And the spacing, everything, because then it's just a matter of copying and pasting. Yeah,
agree. I absolutely agree. And it's actually a good way to write code. If you have multiple ways to write code these days. You can write it yourself. You can use ChatGPT, always good idea. Or you can use Designer, which can do even better job for this type of coding, because it will give you exactly, once you code out the layout in the Designer, once everything resizes nicely, you literally grab and paste the chunk of the code and you're done. And the code that you will grab will be called create content for tab for new field, and it will generate this part. Yeah, that's a plan. Yeah, good plan.
Sounds good. Okay.
Yep.
So I think we can change subject. So I would like to show you something, Maciek. So
yeah,
I asked Liam to solve that issue that you talked about in PyCharm. Let me open it for us.
Okay, remind me.
Yes. And I think I solved it because well, I'm a little bit afraid if Liam can do from like everything alone, so I went ahead with it and tried myself to make sure it wasn't like super difficult, etc. But there are some changes, at least in the way I solved it, that maybe are not like the best ones,
right?
But so we like if we make some compromises, it's okay. That's the situation. Let me show you exactly what it is. In the new simulation wizard, line, yeah, 700 something. It's very slow because Zoom messes up my computer, and my computer is not.
Oh, yeah. You need to get a new computer.
Yeah. Yeah.
Do you know which one to get?
I will probably buy a G series gaming computer or a Lenovo Legion, something like that, a notebook laptop.
Go with Lenovo. Don't buy Dell. Those Dells are not great, the G series. They are cheap, but
Okay.
really, I was looking, or get Asus TUF 15. I got it last year and it's really nice. And they will be on sale, or they are on sale now. You can always upgrade memory to whatever you want and upgrade the hard drive. So that's what I did, and it's a good machine, except I'm working on Mac most of the time.
Let me close.
Don't buy that, really. I'm serious. Not this one. I mean, it's just, I know the price is low, but I was considering myself, but I'm like, no. I've heard many bad reviews. I mean, I've read many bad reviews of that.
So either
let's
Lenovo
see.
Legion or Acer. What?
Asus TUF. I will send you the link to what I have.
Nice, good. Yeah,
I mean, there are newer ones now with much better GPU. The NVIDIA 4070. I have 3070. And
3070.
those guys really raw.
Yeah. And isn't there a problem with overheating?
I don't know. I mean, I haven't experienced overheating. I don't think so. I mean, I'm not playing games.
Running demanding programs, etc. No problems?
I think programs you shouldn't run it on laptop.
I mean, games, etc.
I know. I don't do games, so I don't know. You can ask Gilberto. Gilberto has Asus. And he likes it. I bought for him like many years ago, and he still has it. But Lenovo is good. I like Lenovo. They have much better keyboards actually than Asus. So so I like Lenovo.
I'll keep an eye on it. But send me the Asus one.
I will. But go to Best Buy and see how it feels. To me, Lenovo was like, keyboard was very close to Mac keyboard, which is, I think, the best in show. So if you want to work on it, I would recommend Lenovo then, maybe more than Asus actually.
So Lenovo Legion specifically?
Legion, yeah, i7 or whatever. You have to go and check those keyboards, and the only thing about Lenovo is that they have big power supplies. But it's a good computer. It's it's gonna be gaming computer. It's gonna be heavier than MacBook Air.
Yeah.
But the keyboard and the trackpad on Lenovo, I was really impressed with that. It was on par with Mac pretty much, which is not the case for Asus. Asus is nowhere near in that category.
Nice, good. Okay, so let's come back to the issue. So
yes.
the previous way we were doing the page dictionary was writing one by one and assigning the pages, the page indexes, okay, for each one of them, using the very convenient names like simulation directory, cell type, diffuse, and split. The way we wanted, ideally, was writing a for loop that do all of them automatically. Okay. There are two issues with that. The first one is we have to refer to the titles of the pages.
Yeah.
To do that automatically. So to refer to the titles of the pages, we first have to use the full title, like CompuCell 3D Simulation Wizard, like they appear
on the wizard.
Pages. Yes.
Yes.
instead of using the very convenient short handles.
Look, it's, you know, in a sense, I'll tell you, I think there is a value to using those longer names because at least they are consistent between wizard and the code. So I
Yes.
would say it's not a bad idea.
Mm-hmm. And the second issue, so this first issue is not an issue. We can agree on that.
Yeah.
Okay. So the second issue is solvable. And maybe it's actually better now, but I have to show you what exactly it is. Yes, run. It runs, it works, it generates all XML. So I tested it.
Yep. Are you committing all your changes, Pedro? So what I would do, look, I mean, always, every you know, once you're done with a chunk of code, commit it.
Okay.
There is no worry that you can override because you have history. So
okay.
commit it frequently so that, you know, if you miss something, you can always go back to history and restore it.
Okay.
It's better than actually writing, you know, doing a lot of work on a chunk of code, than committing big chunk of code, because then you're, yeah, you might use those micro changes that you do on the way. So especially that we are experimenting. So that's important.
Yeah.
Yeah, but
okay. I didn't want to like to commit because I wanted to wait for Liam to catch up, but I think
okay. Oh, I see. Okay, no, that's fine. That makes sense.
Okay, because I want his name on it.
Oh yeah, sure,
That's the
absolutely.
idea. Because because the issue we solved last week was on my name in GitHub.
Oh, that's
And
fine.
now I want that Leo and Liam have at least
No,
each one of them something
absolutely. Yep.
in their names. Okay, so the issue quotes here is that instead of using like a floating object for the title page, I actually used the title widget itself. So in each one of the pages, there is you can specify the title without adding a text, text object to the page.
Yeah.
So the downside of it is that when you use the text widget, and like change the font, change the color, etc., do all sorts of fancy stuff. And I think we can change, of course, we can change the font title, but it's a little bit more work, and we have to do that for each one of the pages. So the style changed, and
So for I wouldn't play with fonts yet because Pete is actually working on CSS. This is cascading style sheet that we can apply throughout the entire GUI.
Oh, nice.
So this is the correct way to actually change fonts. So you define a file with styles, then those styles are being consistently applied throughout the app. So let's not worry about the style for now.
Okay. So
I assume that this will be
this is genuinely better then.
Yeah.
Okay. Good. And of course, the other downside is that whenever you have to refer to a page in the code here, you have to use the full name, configuration complete exclamation mark, which is silly, but yet at least it's consistent, like you said. Okay, so this is good to go, right? Nice. Okay. Yes, so that will be in Liam's name. I'm waiting him to catch up. He's not here, he cannot attend, but I will send him the recording. And yeah, okay. And the last thing I wanted to talk to you is Gilberto. Let me stop share and create a whiteboard, because really the screen share is too much whiteboard.
Yep.
So, Leo, thank you very much for coming. You are free now. If you want to go, do whatever.
Okay, thank you.
Okay.
Yep. And
So
feel free to reach out if you need some help.
Okay, thank you. Like I need to for this week, like I have to do like the wizard page.
Yep.
Yes.
Okay.
In Qt Designer, just the style. Don't need to automate everything. Like just the style. I can show you.
Just okay. Thank you. Bye.
Thank you.
Valeo.
Yeah. So Gilberto wants to calculate the pressure in a bubble. I think you
Oh,
are.
yeah. Okay, yeah.
But the bubble does not have a target volume. Okay.
Right.
So the way to do it, like physically speaking, would be to calculate the probability flux of copy probabilities.
Yeah.
So I have a pixel here and a pixel here.
Yep.
Okay. So you estimate the probability that this pixel would copy in this direction and this pixel would copy in this direction. What is the probability? Well, it's e to the minus delta e t. Okay.
Yep. Yes.
And of course, this is if energy decreases, if increases, it's 1. Okay. And then by the difference, so you have a probability ongoing, and a probability incoming, let's say.
Yes.
Okay. And the difference between these two probabilities will lead to pressure. Okay. So a proper steppables to measure the pressure in a bubble, and it has to be like in the interface with another bubble, because if I have another bubble here, you have a pressure exchange here that is potentially different from another place, because the system is not in equilibrium. Okay. So you have to do this calculation in the interface, in this region here. So a proper steppables for that would require first the neighbor loop, which is okay, the getting the pixels in the pixels only in the interface, which we do not have.
Which we do not have.
We do not have. Yeah, we do not have a steppables that gets the pixels at the interface.
Yeah.
And the third thing we need would be something that tells me what is the energy now and what would be the energy if I convert all a certain group, a certain set of pixels to another pixel type. What would be the energy?
Yes. Yes. Yep. Let me actually look, because I coded something like that for Gilberto or Julio. I think this was joint work when Julio was working on.
Julio has a code for that. The problem is,
but it should be here.
he calculates the energy using. He calculates the energy from the energy terms, like algebraically.
Okay.
He doesn't access the energy that CompuCell throws at you, let's say.
Let's see.
If we could access the energy, like the energy now and the energy if I make those changes.
Curvature calculator. That's probability. Hold on. That would be, let me actually look for it. This flow J. Can point you to, let me actually point you to a plugin and see if we can reuse it. So, and let me actually send you Let's see this. Zoom chat, and let's do that. So I'm going to send you this. So this is repo. This is where something similar is already there. Now let me actually curvature calculator.
Yeah.
Yeah, get probability by neighbor. So let's see. This is interest. Oh, field 3D change. So I wrote this a while ago, then boundary pixel tracker. Okay, good. So I think this is the plugin that has. So do you wanna keep this whiteboard? Can I share my screen?
Yes, sure.
So let's do that, because this might be good. I'm wondering, I mean, I could write it, of course. I'm just trying to get more people write plugins. I know Pete, but Pete, he might be busy. Do you want to learn how to write plugins, Pedro?
Yes, sure. Yeah.
Okay. So maybe this could be something. Have you compiled CompuCell on your machine or not yet?
I saw you doing it, but I never done myself.
Because you will need better computer for that too, like
Oh,
practically.
yes, I will. Yeah.
So maybe let's wait for that to happen. Like, are you buying new computer soon?
Black Friday. Yeah, soon.
Like, okay, that's go ahead. So let's wait till then, and then I'll tell you what to do. I'll send you code to install, like the Visual Studio, and then I will set you up with that so that you can compile. And I think it would be great. So I like, in the spirit that James said, well, we have to have more people developing CompuCell. I think I'd rather invest time teaching you or somebody else, in addition to you, how to write plugins, because that way CompuCell can grow faster. Because otherwise, if I'm writing plugin or there's just only so much I can do. But okay, so let me actually share my screen.
Go ahead.
So you have to hide your whiteboard somehow.
Uh-huh.
And I will share this advanced portion of the screen, and this will be here. So this is this curvature calculator. Okay, so let me go through the steps, how you are doing this. Blah, 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 blah. This code, let me actually show you, has been automatically generated by Twedit. Okay, that's how, like, if I were to start writing plugin, I would not be generating those files manually. Every time I have to ask plugin or stepable, I use Twedit generator, because it just saves you so much time, and you will avoid many errors, like silly typos. So, and that's how I can see that it was auto-generated. Okay, so now let me talk about, what do we do? What should we start with? So, are you familiar with C++ classes at all?
I worked with them in some projects, but
I'll show you. That's fine. So okay, that's fine. You don't have to be an expert, because that's the goal. I think you should not be an expert in C++ to write this, but I'll explain what everything happens. So everything that we do in CompuCell sits in namespace called CompuCell 3D. Namespace is not a class. Namespace is like, it's a namespace to avoid like clashes between function names. So, you have function, if you have function called max defined within CompuCell 3D, it will not interfere with global function max if you call it proper. That's the only reason.
Right.
Now, let me actually move this way. Class itself, the plugin, it inherits from base classes, plugin and plugin. Let's say that it inherits only from plugin. This inheritance is totally ignored in this class. Then you have private members, where you have pointer to pods object, pointer to simulator. So pods object runs Metropolis algorithm, simulator calls pods object to perform Monte Carlo step, broadly speaking. Boundary strategy is the object that manages pixel iterations, that it knows, how to iterate over pixel neighbors, it knows the neighbor order, stuff like that. Cell field, G, is the 3D array that where each pixel is a pointer to cell object. So, we can have 10 cells in the simulation, but our lattice can be 100 by 100, right? So we'll have 10,000 pixels, but only 10 cells, 10 objects. So a pointer to an object is actually being stored on the cell field. Not a cell field, not a cell itself is being stored, it's a pointer. So remember, you have 10 cell objects, they sit somewhere in memory, but pointers to them, addresses, are being stored on the cell field. Neighbor tracker accessor pointer is a way, it's an object that helps you, for a given cell, will let you access all the information about cell neighbors. And similarly, boundary pixel tracker plugin is a plugin that stores information about boundary of each cell. So, pixels that lie at the boundary. Now, let's see. Those functions that I'm highlighting here, all those functions, they are defined in the plugin. So you have to implement them, those guys. But don't worry, if you don't understand, if it sounds cryptic for now, don't worry about this. This function we're gonna ignore for now, but there is only just one function, get growth probability. Get growth probability is a function that returns what I believe is the probability that you define on the whiteboard. Okay, so how does this function work? Well, it takes a point at which you wanna, it takes a point at the boundary at which you wanna compute this probability, right? This P in minus P out, or the other way around, right? It takes a cell and a neighbor cell. Then it takes J, which is coefficient between those two, and it takes temperature. I believe that this is temperature. And that's what you will get now. Get probability by neighbor. And then there's another function called get probability by neighbor. So this function, imagine you have a cell that has 5 neighbors. What this function will do, it will iterate over each neighbor, and it will compute this for the boundary with each neighbor, it will compute the probability. P in minus P out. Does it make sense so far?
Yeah.
And the idea is that this is a plugin, but the idea is that this plugin is being made accessible from Python. So in Python, you have a steppable, right? You have a steppable where you have for loop, where you iterate over each cell. Okay, so we iterate over each cell. And then for each cell that we iterate, we are calling this function, get probability by neighbor. And this function will return us, hey, what is the probability P in minus P out between this cell that I'm currently in and its neighbor? And then it will return it as a dictionary. So you will have dictionary so this long is ID of a neighbor. So for a cell 1, let's say that my ID of the cell 1, ID of the cell that we are currently at is 1. And cell with ID 1 has neighbors 2, 3, 4, 5, 6, right? So this dictionary will have entries 2, 3, 4, 5, 6, and the value will be the pressure between cell ID 1 and cell ID 2, cell ID 1 and cell ID 3, and so on. So what I think, really, let's go here, sorry. Let's go to the definition. Extra init. So let's actually see how it's done. There is a little bit of setup that's involved, that's done in extra init. Let's not worry about it. We will worry about it when we start coding up your module. And this is the function that we will call from Python. But this function, I'm pretty sure, calls, let's see what it does. Calls this get growth probability. So let me actually see where is this function called. Okay, good. So as expected, this is the function that you call from Python. And this function, in turn, will make use of this get growth probability function. So get growth probability, I'm pretty sure that implements this, your atomic unit of the calculation, that where you draw a pixel 1, pixel 2, and you told me P in minus P out. So this is what get growth probability will give you. It happens to be growth probability, but I'm sure that the calculations are as expected. So let's see how it works, really. Let's see for a single pixel. So we're looking at the single pixel, okay? And we have cell and neighbor cell. So E0 minus E5, I don't know what it is, what it means, but we'll figure it out. So we iterate over, what is this? So this is the maximum index of pixel neighbors that we take into account. So it will be, so depending how you set it up, whether you're looking at first or second nearest neighbors, this will be either 4 or what is second nearest neighbor, or 8 into D. So we iterate over this, and then we are getting a neighbor cell that is located at this, at the pixel that belongs to neighbor point. So in other words, let me actually start drawing something. I have drawing.
I got it. So you're looping over the pixels in the neighbor region.
Yeah, exactly. Yeah. And then local neighbor. So local neighbor cell. If local neighbor cell, meaning local neighbor cell is the pixel that's at the neighboring pixel of the boundary. So it says if local neighbor pixel is different than neighbor cell, I'm adding J to E0. If local neighbor pixel is different than cell, meaning the cell that we are considering now, I'm adding J to EF. And then if EF is less than E0, I'm returning 1, the growth probability.
Mm-hmm.
Otherwise, I'm returning the difference. So this is where things might change. But the whole idea of this loop here is essentially to compute delta E for probability. I mean delta E for associated with the potential change when we move pixel in or out.
Yeah.
And I mean, it's written in a compact way, so we might have to check if that's indeed what it's doing, but I'm pretty sure that this would be correct logic. But again, that's already coded up. So the only thing that would we would have to do is to, you know, freeze cell. So I would create square cell, okay? Like your phone composed of square cells, right? And I'm just trying to think. Because this is for phone. So J, the coefficient of contact energy is the same, right? Between every single cell. Is it true? Maybe not.
Yes, yes, it is.
Yeah. So I'm just trying to think. Let me think for a while. Okay, no, that makes sense. That makes sense. That makes sense. So phone, yeah. So what I would do is essentially, maybe instead of actually creating square cells, we can load simulation, phone simulation that Gilberto has from the PIF file. So we could ask him, hey, give us, you know, a snapshot of your simulation in the form of PIF file. He can generate it. We can load it, and then we can freeze every cell, and then pick a pixel that we know that belongs to the boundary of a single cell, and we can manually compute what the change should be, and I think that would work.
So this get growth probability, this is for 1 pixel of the boundary, right?
Yes, that's for 1 pixel at the boundary. Why? Because
the previous function that you showed computes the average in the entire boundary. Is that true?
Let's see what it does. So let's see how it works. So this is the stuff that this is the dictionary we want to return: cell ID and the growth probability. So if cell is medium, we're not doing anything. We are returning empty map.
Why? Well,
just because we want to return. So let's say, I don't know when it happens and when it would happen. It's probably, this shouldn't happen ever. This condition should never be called. But if for some reason somebody does something like, I want to compute the medium probability.
Well, yes. Why
not?
Why not? Exactly.
Yeah. So this is where we might have to change things. Yeah, that's a good point. Good point. I think this was written for a situation where the lattice was filled with bubbles, so there was no medium in a sense. So this is a case where it could handle. So we have neighbor tracker. So this object, what this object does for a given cell that we pass to this function, it will return neighbor tracker object, then pointer to neighbor tracker. And neighbor tracker has all the information about cell neighbors. So here we are doing a loop over neighbors of this cell. And for neighbors, for each neighbor, we are creating entry in this dictionary. So we are making pair where we take neighbor ID and we assign 0 value to the probability. We are initializing this dictionary. Okay, so that's what this function does. Again, if we didn't find any neighbors, we return empty map, which is the correct thing to do. And then we are using, so here, what's happening here? So we take boundary pixel plugin, the plugin object. We are getting from it a pointer to an object that will access information about pixel boundaries. The reason why there is this level of indirection is because things like list of cell neighbors, boundary pixels, cell pixels, those attributes are all added at the runtime. Okay, so they are not hard-coded in cell.h. Okay, so that's why there is this somewhat confusing level of indirection. It sounds like extra work because it is, but it gives you more flexibility. But when I code this stuff, I'm writing this code almost mechanically. And by the way, this code, a lot of this code can be generated and is generated automatically into Edit. So this object is object that allows us to get the information about boundary pixel tracker for a given cell. So I'm using this pointer, and here in this line, I'm actually accessing pixel set, which set is like, it's a C++ container. It's like a list or a vector in a sense that contains every pixel, the coordinates of every pixel that belongs to cell boundary. All right. So that's what it does. And CompuCell does this compilation behind the scenes. So if you ever have to get a list of pixels that belong to cell boundary, you can write those two, you can copy those two lines, and you will, and this set will have information, will contain every single point 3D coordinates of every point that belong to cell boundary. Now, just to complete this, so vector is like array, okay? List is not like array because you cannot access in directly element of the list. You have to iterate, go from list to list. I mean, go from one element to the list to the next element to the list. It's a linked list. Set is a container where you cannot access things directly by index. You also have to iterate through every member of a set. But set has also another property that if you insert to a set a point that already exists, this insertion will be invalidated. So set is a container that does not allow duplicates. You can have duplicates in list. You can have duplicate entries in 3D array. You cannot have duplicates in what shall we call it? In a set. So that's why we use sets to eliminate duplicate members. So you can insert, you have set of integers, and you insert integer 1, 2, 3, and then you insert 5 times integer 2. Those extra inserts of integer 2 will be ignored. Final set will have 1, 2, 3 only.
Yeah.
And that's what we want here. All right, so now here we are iterating over every single pixel of the boundary. Okay. We are iterating over the pixel. So this is our boundary pixel, this guy. Then for this boundary pixel, we iterate over every pixel neighbor of this boundary. Okay, that's what we do. So here we are at the boundary of a cell, and here we're checking every neighboring pixel of this boundary pixel in this guy, in this loop. And then we are fetching, hey, let's see what's the cell at the neighboring pixel of the boundary pixel. If neighbor cell is different than cell, we are computing this growth probability. Okay, and we are adding this probability. We are literally adding those probabilities. And that's all we do. So we go through every boundary pixel, and then for each boundary pixel, we walk over its neighbors and compute the probability of going in and out. And we sum all those probabilities for each interface between cell and its neighbor. So this logic might need to be changed. I mean, that's how Gilberto and I think Giulio wanted this to look for their previous project. You might need to change it, but regardless of that, I think the mechanics, the core code will be the same. I mean, you will
it's
actually
not
write.
normalized. That's the weird stuff. If you go to that line where you add probabilities, and then
This
you
one.
turn like the summation of all probabilities. This is weird because this is not
Yeah.
this is not normalized.
It's not normalized. Exactly. It's not normalized. I think so. I asked them what are they doing with that, and then I think they had code that was calling this, and they were normalizing those probabilities. So
Okay.
I think, let's say you have, okay, that your map is okay between cell 1 and 2 you have probability 5, between cell 3 and 4 you have probability 0.1. I think they were doing normalization based on those. So there was a normalization done outside of those functions.
Mhm.
But they really want, and we should ask Gilbert about this code because he must have this code somewhere. And and maybe I
It
have this
returns the
code.
entire map. It returns no. Wait. Oh yeah. It does not normalize. That's weird.
It does not normalize here. Normalization is done
Mhm.
in Python.
Mhm.
The reason why they wanted to have these functions like this is because doing those loops and implementing everything in Python, which they did initially, was costly.
Mhm.
So I literally took their Python code, translated to C++, and I told them, hey, this is what your Python code used to do very slowly. This is 100 times faster, but you have to do normalization outside. So we can look at their code, what it does. Why don't you ask Gilberto what happened, like what he did, and then I think we'll have an answer. But to me, it sounds like if you have to write another plugin, what should we call, like bubble pressure plugin or probability based plugin?
No, I think this is what he needs. I mean, it's for him. He is asking about that.
Yeah.
It
Second point.
exists. It is implemented. He
Yeah.
only needs to call it.
Yes, and he, I don't know who wrote the previous phone simulation, whether it was, I mean, it's a bit, maybe Julia was coding it up, but I remember that we did this already. So if there are changes required, we can do those changes.
Mhm.
But the mechanics of the code, how it's written, it will be the same. The only thing that might change will be, maybe this calculation will look different. But I think it should be fine.
And so, how do I call the plugin and use the method in the
Yep.
samples? What
Let's
exactly?
see.
How does that look like?
I would search. I'm not sure if I have it. Let's see py. If there is anything that I have in. I unfortunately don't have it, but I can take a look. Hold on, let me actually get this here. I can take a look. Oh, you're sharing it with me. That's interesting. Okay. What is this? Actually, move this away. Okay, and then let me go here, and I want to search. Right. Second. And this, and let's see. Ah, no. I did something silly. Copy. This should be in. So Just trying. Just looking through my emails. Okay. I'm actually. Will I actually forward this to you? Pedro. So there will be a few emails from me where I'm forwarding. Hope this is to me. Forward. This is 2018. So Pedro. You know, this may use old CompuCell 3D, but you can easily translate it to new one. So let me forward. Oh gosh. Okay, so this is what I did. So this is now. And I don't know what I'm supposed to. Trying to see if there is any attachment, but I think, wait. Let's see if I can forward this to you. Yeah. Are you right, Pedro? I sent you 3 emails, maybe 2, I don't know. One of them has, let me actually open it up and see what it looks like. Curvature calculator, the CPP. What is this? Oh, wait. I think we should have curvature calculator demo here. So let's go to demos. Plugins. Maybe this one. Let's see this. Now. No, that's not it. Maybe we should add a demo because I have this. I've actually saved this. Save. CPP demos local. Not sure if this will work. Open project.
I think there's something wrong with the calculation metric.
There might be.
Because what you want is the difference between the two probabilities.
Yeah.
You have a pixel, a source, and a target. You have to calculate the probability from source to target and from target to source and calculate the difference.
Exactly.
If you calculate only one way, you are getting the wrong pressure. Because
but it is calculated both ways. I'll show you where.
The pressure is 0.
Yeah, no, I know, but I think it is calculated correctly. I'll show you the trick, but let me actually open. Why is Player so stupid? So I'm gonna open this. Oh, to edit will open it. Okay, never mind. This one should be open. Okay, never mind. So let me actually unzip this stuff. Let's go somewhere. It's more useful. And let's do C demos local, and then I'll show you what. Yeah, I know what you mean. Because see, the issue is. I'll tell you what the issue is. Okay, so let's look at this first. This is curvature. Where are we? This one. Home. I don't know. Did I get this from Gilberto? Yeah, this looks like it's Julio stuff. And it's Python 2. You know, you can read Python 2. It's like Python 3. Estimate curvature and growth rate. So this is what he's been doing. So, and I translate. Oh, I see. So that's what I trust. So this is my code, actually. So calculating growth rates at each dry interface. So we would get this dictionary. Sorry, not dictionary. Probability by neighbor. And then we have to see growth probabilities. What he does with that. So there is dry probability, common surface area. So he scales this probability by common surface area between the two cells. And I don't know what he does. Anyway, so this is what Julio did. So we might need to reach out to him and Julio and figure it out. And this get growth probability, this is how it was coded. You remember, we saw the similar stuff in, what is it called? In C++. So really, your question was, how come, and E0, EF. So I think this is the trick. It's like, you have current pixel, and when you extend this pixel, so actually this calculation, I think, summarizes what you just said, but except it's written differently. It's written in the form of for loop. So let's draw. Where can we draw?
But this is, look, this is for a single pixel.
Pixel, yes. So that's what Julio had initially, and I translated it into C++ because it was much faster. But you can see that for a single pixel, he computes when explain this different.
E0 is the energy now.
Yeah.
The way it is.
So it says current energy when pixels still belong to N cell.
Yeah, the current energy. E0 is the energy now. And EF is the energy after you do the copy, after you do the exchange.
Right.
So it doesn't do backwards. It doesn't grab the target pixel and calculates what happens if you copy the target to the source. Because what really matters is the difference between these two probabilities, outgoing and incoming.
Yeah. No, I know. That's a good point. But so we are picking, hold on, so picking this cell, neighboring cell. I think I'm gonna do this. Right. So we might have to. Yes. So I think in that case, we might have to call this twice.
Yes.
Yeah. Yeah. Oh, we might have to actually
Then grab the probability, normalize, do the difference,
yeah,
and then you have pressure.
yeah. Yeah. So
And
let's
there is still another thing. Maybe it's like too minor detail for us to care about, but I think it could play a role. Let me show you what I mean. So when I have, let's say I have an interface here,
yeah. Yeah.
and um let's say uh I have an interface and a pixel like this, and the
Yes.
other interface is correspondent.
Yes.
Okay, so and this is bubble A, this is bubble B, and so it's favorable for this pixel to be overwritten by a B pixel. Okay, let's say J is 10.
Yeah.
Okay, so you have a pressure associated with the fact that it's favorable to overwrite this pixel because J is 10.
Yep.
If J is 20, your pressure is not higher. You have a pressure in this direction, right?
Yeah.
If J is 10 or 20, the pressure is the same because the energy, because the probability is 1 in both cases.
Right.
But physically speaking, you have a higher pressure if J is 20.
Right. Right. Yes.
We are not taking that into account.
We're not, no, exactly as you said. Yes.
Maybe it makes sense because in CompuCell, if J is 10 or 20, it doesn't make the bubble shrink faster.
Yes.
Right?
Correct.
Which doesn't reflect reality. In reality, the bubble will shrink faster.
Yes.
So
yes.
maybe this is like a fundamental problem in CompuCell that your bubble cannot shrink faster than 1 pixel a second.
Yep.
The surface.
That is an issue. Yeah. So there is maximum speed at which things can move. Yeah. No, absolutely true. Yeah. So computer dynamics, in a sense, it's you can modulate so you can modulate like you can recapitulate, this law, force is proportional to velocity up to some point, because your cell, there is a maximum limit at which cell can move in one Monte Carlo step. Yeah, and this is Potts limitation or not limitation. I mean limitation, yeah.
I'm thinking if distinguishing between these two is like critical or not. Maybe it's not.
But look, Pedro. Okay, let me actually. Why don't I have my drawing board? Where it's like when I'm sharing a screen, I can.
So you can
annotate. There you go.
Yeah.
So I'm just wondering if you can see my pixel. Can you see my pixel? No.
You have to click the annotate button. There is a
I did. I'm just okay. Let's do this. Draw. And so let's say I want to compute, well, at this, we're at this pixel. Oh,
sorry. Let me undo.
Do it again.
There we go.
Okay, sorry. So where is my, let me erase my stuff. So what do we have here? So we have this boundary and we want to compute what happens if we move in this direction and what happens if the cell B moves in that direction, right?
Yes.
All right. So let's start. So what, all right. So when this cell moves in that direction, we have, before we have 1, 2, 3 edges. After it moves, meaning we would have something like that, we would have only one edge. So we have 1, 2, 3 goes to this. So we lose 3 edges, we gain 1.
Mm-hmm.
If cell, where is it? Mouse. Now, if this cell extends in this direction, like this, we have 1, 2, 3 edges. Now we will get 1, 2,
5.
1, 2, 3, 5. Yeah. And I'm just wondering if this loop here that we see here, does it cover this case? Because I think it might actually do +5. Yeah.
Yeah, so the way I'm doing, I was discussing, we also have to consider this,
Yes.
this, and this for all edges.
Yeah, that's right.
All possible edges from the neighbor copy range. So if we can copy diagonally, we also have to do this,
Yeah.
this,
Yeah.
and this. So which one is the accurate one?
Which one is what?
Which one is the most accurate one? The way it's done here in the code,
Oh,
where you don't care about the outgoing and incoming, which I think it's wrong,
yeah.
or the way I am saying it should be.
So looking at what's in the code, current energy, which is current energy, and then energy from the fleet pixel.
Oh, actually, there's another way. There's a better way, which I think keeps simple and solves this problem. Let me erase everything.
Yeah.
Oh, yeah, so let's suppose I have a boundary this and another cell boundary here. So I think the calculation should be first you scan all those pixels
Yes.
and calculate the total energy after you convert all of them into red cell. And then you do the same, but from the perspective of the red
The
cell.
other cell. Yeah.
And then you do the difference. I think that's
yeah, exactly. Yeah. So in that case, yeah, we could still use this logic, but we'd have to call it multiple times. The get probability, or rewrite get probability function completely. So what I would do really, and this might be actually good exercise without you writing C++ code. I would work with this get this function in Python. Because you get access to the same boundary strategy, to all the pixels. And you might see if you know, if this is correct. So I would encourage you to actually, you know, maybe play with this code that Julio wrote and modify it in Python before doing anything in C++.
Mhm.
Because you can, in Python, you can do everything. You can compute, you can iterate over boundary pixels, over neighbor pixels, like really anything. And I think this code that he has shows it. And I think the syntax is the same as before.
Yeah.
Even though it's Python 2, it's carries over. So, but you're right. I mean, I mean, all of that we talked today, it will be probably small modification on top of the code that I shared, this curvature. It might need to be changed. You're right. If you are doing this, you know, P in and P out, the difference. Does it make sense?
Yes. Yes. Thank you.
Yeah. So hopefully you will
Mhm.
you will get something out of it. You know, translating everything to C++ is easy because we have the skeleton.
Mhm. Yeah.
But figuring out, like, just thinking about this boundary picture that you drew. So
Yeah, we
indeed,
just have
you're
to
right.
do it
I mean,
twice, calculate twice. I think that's the point.
yeah. Although the funny thing is that if you have this flat boundary, it will not. Just thinking. It will cancel out, probably.
No, it will not.
Will not?
No, in the flat, yes. In the flat one, yes, it will cancel.
Yeah, if you have curved boundary, like the first drawing that you draw with this
Yeah,
protruding.
the flat one, yes, it will cancel. And we want that. You see, if it's flat, we want to cancel.
Yeah.
However, if it's flat and you do not calculate the difference from the perspective of cell A and perspective of cell B, you always have a net pressure because of temperature,
Exactly. Yeah, you always have net pressure, right?
which doesn't make sense. They cancel.
So let's see what happened here, like going over this code. If let's imagine that we have like fixed boundaries. So I'm working over this pixel, and if pixel ID is you're right. That's funny. It is funny. Indeed, you would have a pressure if you don't do it both ways.
Yes.
You would have exactly pressure. So if you consider just one pixel, the difference will be 3J. Plus or minus, I don't know, but the outcome of this will be 3J. If you consider boundary pixel, if you consider neighbor, the boundary of the neighboring pixel will be maybe that's how they did this. Maybe this thing here cancels things out. So maybe the calculation that you are talking about, you know, this P in minus P out is actually done here. Because those, we would have, probably that's true. Probably that's true. So probably this is correct. This calculates P in, but the calculation, this P in minus P out, it's not done here. That's just a component, but this calculation is done here.
But it has to be called twice for each pair of cell.
I'm pretty sure that this is the case.
And it's not being done here, I think.
It's not?
No, I don't think so. You are looping over the cell neighbors.
I get a cell.
Okay.
And then I get cell neighbor.
Looping over the cell neighbors of cell. So N cell is the neighbor cell, and cell is the source. So when you call here, the get growth probability,
Yeah.
you are calculating it from the perspective of cell,
Yeah.
and then you loop over all n cell.
Yeah, exactly. That's right. No, that's correct. But I thought that there will be, is there another part of the code where this is called? So let's see.
Oh yeah, maybe they correct later.
Exactly. And I don't know really.
Mm-hmm.
It
Let's
might be
see.
pretty-
What is the name of that function? Go down again.
Get
Get probability by neighbor.
name.
Where is it called?
It's called here in this for loop over all cells. But again, it might be still, I mean,
No, it's not done.
yeah,
They don't do the difference.
they don't do the difference, yeah. But I think anyway, you know what to do in a sense that if you want to compute the difference, the components are in this code that I've sent you. So I would just play with this. Translate it into Python 3. It's not that much of a translation. Most of the things carry over. And this is all Python code. So in other words, I don't think we are calling anything. Yeah, this is all Python code, I believe. Well, maybe not. Maybe we are calling, yeah, we are calling this guy. But we could, but instead of calling this from Curvature plugin C++, you could call the Python function here. I would use this code really to play with.
Yeah. And are you sure it works for 3D case normally? I think it does, right?
Yeah, it shouldn't matter really. Boundary strategy essentially, that's why you work with boundary strategy. It doesn't matter whether you're in 3D, 2D, hex lattice, it will give you the list of neighbors, pixel neighbors. That's why it's so useful.
Okay, I will report to Gilberto, and maybe soon I will start working on it, but I cannot promise anything now.
Yeah, no, I know. I mean, you're busy too, and so, but I think it's almost there.
Mm-hmm.
Only thing that we might have to do once you have your logic finalized in Python, we can translate this to C++, and you know, I can help you with that.
Mm-hmm.
And I can show you actually how we can working with what is it called, Curvature plugin, how we can add a new function, and how we can add another name to Curvature plugin so that it's more generic. It will be like probability-based pressure calculator or something like that, maybe something more concise. But I think this could be good exercise for you to see how you can add functionality to a plugin. Instead of writing full plugin from scratch, we can just add one function to Curvature plugin that actually does computation that you want. But let's get Python versions first, because that's how you should always actually almost always work. Python is fast to develop in. C++ is slow and it's more involved. And it's slow to develop. It's fast to run. But I kind of think that this will help solve this problem. All right,
Okay.
Pedro, I have to run. That was a good meeting. Hopefully we've learned a lot.
Yes, sure. Thank you. Thank you a
Posted
lot.
how things are going with Liam and Leo. And let's meet, maybe I mean, you decide when to meet.
Yeah, I will send an email everybody just to check availability, and then I schedule another.
That's excellent. Are you traveling this week or staying in Bloomington?
I don't know what I'm going to do. I'll probably stay, but if a crazy plan arises from girlfriend, etc., then I will travel.
Can you stop recording for now?
No.
We can stop recording.